All right, this train, we know the distances should be the same, so let's set up our two distance scenarios. You have distance 1 for the first train equals rate times time. So the rate of that first train we don't really know, so we leave it as an R. But as far as its time, it left at 3, and the other train caught up at 10, so that means it traveled for 7 hours while that was going on. The second train, set up the same way, distance equals rate times time, though the rate and time might vary from the first time. The rate of this train, we don't really know either, except that we know that it was going 72 miles per hour faster than the first one. Well, the first one we called R, so this one we can call R plus 72. And then the time, it started at 7 p.m., went to 10 p.m., so it had 3 hours worth of time that it was traveling. And we had decided we were going to set these equal, so you have a 7R is equal to, I'm going to put that 3 in front, and let's solve. Distribute. Subtract the 3R over here to the 7R, so I'm going to have a 4R equals 216. Divide both sides by 4, and you get 54. That's the rate of the first train. The question says, what is the speed of the 2 train? So okay, so that one's 54. So then you come over here, add 72 to it, and those are your 2 rates for your trains. Okay, one more. 2 planes, which are 1,995 miles apart, fly towards each other. So we've got the scenario where one's going this way, one's going this way. Their speeds differ by 65 miles per hour. If they pass each other in 3 hours, what's the speed of each? Okay, so I know that their total distance right here is 1995. They didn't necessarily travel the same amount, but I know the total. So I'm going to take my first plane, add it to the distance of my second plane, and it will equal that 1995. This is one of those types where you know the total distance between the two. So you set it up kind of the same way at the beginning. D1 for the first plane. Let's see, we don't really know the rate. But we do know that they pass each other in 3 hours, so they each are going to travel for that 3 hours. So I'm just going to write R times 3. For the second plane, again, D equals RT. The rate on this one, again, we don't know, but we know that the rates differ by 65 miles per hour. So what I could do is take the rate of the previous plane, and if they differ, I could either subtract or add. As long as they have a difference, I'm going to go ahead and subtract 65. And then the time is still 3. And remember, we're not setting these equal. We're going to add them and set them equal to that total distance that we know that it equals. So I'm going to have a 3R plus, and then I'm going to have a 3, stick that in front, R minus 65 equals 1995. Okay, distribute to get rid of the parentheses. Okay, I'm going to combine my like terms, which is going to be a 6R, but I'm also going to add this 195. I'm kind of running out of room and time, so I'm going to hurry here. Add the 195. So I'm going to have a, oops, let me clean this up. 6R is going to end up equaling, what is that? $22.90. Nope, sorry, $21.90. Divide both sides by 6. R is going to equal 365. That's a rate, so it's miles per hour, and since that's what R equals, that's the rate of the first plane. So that would be one of my answers. My other answer is the other plane, which is going to be 365 minus 65, so it would be 300 miles per hour. Hope this helps you out.